So here we look at the 2018 higher level DCG paper, question A4. So what we're essentially asked is to find the dihedral angle between OAB and OAD. Really, what these are, they're just two different planes. So what I'm going to do here is shade in one plane in red and one plane in blue. So we can forget really about everything else in that question, because the main thing that we're trying to view here is the line of intersection. So it's the line of intersection where the two planes meet. So it's where this blue plane and where this red plane meet, and that's what we call the line of intersection. So if we take this example, so what we have is two planes, and those two planes are meeting at the line of intersection. So if we can find a point view of this line of intersection, we can find the dihedral angle. So there's our line of intersection. If we look at a point view, we can see the line of intersection between both of them. So there I am isolating the line of intersection, and if I first of all view in perpendicular to that, what that is going to give me is a true length of the line of intersection. So I'm going to set up a XY line perpendicular to the line of intersection, and I'm going to project all of the points that I need. So not just the line of intersection, but also two other points. So a point on the blue plane and a point on the red plane. So I'm projecting everything parallel to the line of intersection. So that's going to give the line of intersection as a true length. So since I'm viewing in the plan, I'm going to find a new elevation. So all that I'm going to do is take my heights from the old elevation. So what I always try to remember, I'm going to step back one x1 y1 line and step back two views. And again, it's the real important point here to remember is the point of your compass will always remain on a XY line. It never leaves that. So we always will take a height from an XY line, and we also will step height or distance away from an XY line. So I'm just labeling those points, and I'm going to redraw these planes. Again, it is all that I'm essentially drawing is a new elevation, and it's just going to look slightly different. And again, I'm going to use my color code, and that's going to find there my true length. So that's the true length of the line of intersection, and now all that I want to do is view in along that line of intersection. So if we view along the line of intersection, this time it's actually going to give me a point view. So it's like if we took up your pencil and if we looked in along the end of our pencil is going to turn into a point view. That's what essentially is happening with our true length. So again, I'm going to step back one x1 y1 line, step back two views, remembering that the point of my compass will always stay on the xy line, stepping my heights off. And again, it's always good practice to label the points as I'm going along. So the line of intersection now changes not into a line anymore, but it turns into a point. And what we should find, and we know when we're going to be correct, is when we will find our planes now turning into lines, the line of intersection turning into a point, and there we have the dihedral angle between two planes. So if we refer back to the model that we just made, there are the two planes, we have the line of intersection, and if I look in along the line of intersection, we get a point view. So part B of the question asks us to find the angle between the cables OA and OB. So really what I'm just going to do, I'm just going to concentrate on the triangle OAB. So again, if we have any triangle, what I'm going to do here is I'm just going to draw a horizontal line across the triangle. So if it's a horizontal line in one view, in the opposite view, what I'm going to find is a true length. So all that I've drawn is a line across the plane, or across this triangle OAB. So now I have a true length. So if I look in along a true length, what I'm going to find is a point view. So if I find a point view, what this triangle is actually going to turn into is a line view. So I'm just finding the same triangle, and really, since I'm viewing in at the plan, I'm going to find a new elevation. And this new elevation, because I'm looking along a true length, what I'm actually going to do is find this triangle as a line view. So the new elevation is a line view. It all comes from drawing a horizontal line in one view, finding that same line in the other view, which makes it a true length. And what I have now is the plane OAB as a line view. So if we take an example here of my set square, there's the set square as a line view. If I look in perpendicular to it, what I get is the true shape of that triangle. So that's the reason I'm going to set up a new XY line parallel, and this is going to give me the overall true shape of this triangle. Again, there is lots of different ways of doing part B. I just like doing it this way because we're dealing with just horizontal lines and true lengths. So stepping back from one x1 y1 line, stepping back the view, again the point of my compass will always stay on the XY line. So in this case it overlaps my part A, but that doesn't matter. And we've B. So what I'm going to do, I'm going to draw in this triangle, the triangle OAB. Again, I'm just going to heavy it in a little bit more now so we can see it. And looking back just at the question, it asks us for the angle between the cable OA and OB. So what I have now found is the angle between OA and OB. So I'm just going to highlight it in. That's that question.